Welcome to the session on projectiles, horizontal and vertical components. The objective for this session is to resolve velocity into components. Consider a particle being projected at an angle alpha, as shown here, with velocity u. We're going to resolve the velocity into components acting horizontally and vertically. So ux, as shown here, and uy, as shown here. Uy can also be denoted as shown. So cos alpha equals ux over u, and sine alpha equals uy over u. From the first equation, we have that ux equals u cos alpha, and from the second equation, we have that uy equals u sine alpha. So we can replace ux and uy as shown by u cos alpha and u sine alpha. So the horizontal component of the initial velocity u is ux equals u cos alpha, and the vertical component of the initial velocity u is uy equals u sine alpha. Now let's have a go at an example. A particle is projected from a point on a horizontal surface with initial velocity 35 meters per second at an angle alpha above the horizontal, where tan alpha equals 5/9, as shown in the diagram. We are required to find the horizontal and vertical components of the initial velocity. Also, given that the vectors I and j are unit vectors acting horizontally and vertically in a vertical plane, express the initial velocity as a vector in terms of I and j. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We are required to find the horizontal and vertical components of the initial velocity. The horizontal component is 35 cos alpha using trigonometry, and the vertical component is 35 sine alpha. So since we have tan alpha equals 5/9, and tan alpha equals opposite over adjacent, we can find the hypotenuse in this right angle triangle. So h equals the square root of 5 squared plus 9 squared. And therefore h equals the square root of 106. This will now allow us to find cos alpha and sine alpha. Therefore, sine alpha equals opposite over hypotenuse, and in our example, this equals 5 divided by the hypotenuse, which is square root of 106. And now for cos alpha. Using the formula adjacent over hypotenuse for cos alpha, we have that cos alpha equals 9, which is the adjacent, divided by square root of 106, which is the hypotenuse. Therefore, in the horizontal direction, ux equals u cos alpha equals 35 times 9 over square root of 106, which equals 315 over square root of 106, which equals 30.6 meters per second. And similarly, for sine alpha, or substituting sine alpha into our equation for uy, gives us 35 times 5 over the square root of 106, which equals 175 divided by the square root of 106, which equals 17.0 meters per second. And so we have the horizontal and vertical components of the velocity. Now let's take a look at part B. We are required to express the initial velocity as a vector in terms of I and j. Now from part A, we have these values for ux and uy, the horizontal and vertical components of u. Therefore, u equals 30.6i plus 17.0j. Now let's take a look at another example. A particle is projected with a velocity u equals 7i plus 8j meters per second, where vectors I and j are unit vectors acting horizontally and vertically in a vertical plane. We are required to find the initial speed of the particle and the angle of projection. Pause the video and have a go. Press play when you're ready to view the solutions. So let's draw a diagram first. We have that the initial velocity is 7i plus 8j. So we can draw this as 7 meters per second in the x direction, as shown here, and 8 meters per second in the y direction, as shown here. And the resultant velocity is as shown, u. Now using Pythagoras, we can find mod u. This equals square root of 7 squared plus 8 squared, which is equal to the square root of 105 meters per second. Now let's find the angle of projection for part B. We have that tan alpha equals opposite over adjacent. Therefore, in our example, tan alpha equals 8, which is the opposite, divided by 7, which is the adjacent. And therefore, alpha equals tan inverse 8 over 7, which equals 48.8 degrees. So we have from part A, mod u equals square root of 105 meters per second, and from part B, alpha equals 48.8 degrees. Therefore, the initial speed is square root of 105 meters per second, and the particle is projected at an angle of 48.8 degrees above the horizontal. This brings us to the end of this session. If you have understood its contents, you should be able to resolve velocity into components. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.